Let us dry run the program so that we can validate what we have learned and what we have written is giving us the output that we are looking for. So here again, the input is an array integer, and then the output is the modified array where the elements are sorted. So let us take an example. Let us take an example of 5 elements for the easier understanding. And we have elements say 6, 17, 2, 31, 4. What happens? So the array index starts from 0 to 4. This is our input array, and let us call this as ARR, as we are using ARR here. Hey, by the way, so I forgot to place this minus symbol in the previous section. So please correct that. So without this, the swapping doesn't happen. So it is one single line with the minus symbol here, so that the swapping happens. Now, so let us take, so I0, J0, right? So I0 and J0 to start with. You're starting I0 and it goes up to N, or N is 4. Then another loop begins with 0 and this also goes up to 4. What is happening here? Array of I, which is array of 0, this one 6, is 6 less than array of J. J is also 0. So 6 less than 6, false. So come back. Now J is incremented, J became 1. So J is here. Now comparison again, array of I is still here, right? I did not get incremented. I is still pointing at 0. So J has become 1. So array of I is 6, is less than 17. Yes? Yes. So then the swapping takes place. So when the swapping takes place, the next place of an array is 17 and 6 are swapped, and then rest of the elements continue to be same, at least for now. Then what happens? Your J is incremented, your J is here, right? So J is 2, J is here, and then you compare array of I. Array of I, the new I value is 17. Is 17 less than 2? No. So your J is incremented again. So your J is now 3, 31. Is array of I is 17 less than 31? Yes. So now the swap. So therefore the new array would be 31, 6, 2, 17, 4. So your J was here, your I was still there. So now one more iteration. We go, now J is here, 4 and 31. Array of I, 31 less than 4? No, false. So this is the output of first iteration being completed. So now this loop terminates because J is reached to 4, 4 is not less than 4. Therefore it comes here, and now I became 1. Now your I became 1. So when your I became 1, you operate on this new array. Your I is not here anymore. I is at first position. Right? So now you start the same process again. That's what we meant. Repeat the steps from 1 to 3. Now, when you start that, we'll take this as an example and wind it up so that you will understand the entire process. So what happens here? Array of I is 6. J is still 0. Right? So you compare the array of I value 6 and array of J value 0, 31. So 6 is less than 31, therefore you swap. So the next you will see 6, 31, 2, 17, 4. So now we get into the second iteration where I becomes 1. Right? So I has become 1 now. Now when your I is 1, so in this new array, your I is pointing to 6. So we repeat the entire process again. So saying now array of I, that is 6, is less than array of J. J is at 0, so 0th value is 31. So therefore, you will have the swapped value. Now 6, 31, 2, 17, 4 is a new array. And then J gets incremented, I remains at 31. And then you compare against all the values. So 31 will not be less than any of these numbers. So therefore, this array remains the same. Now the inner loop exits, the outer loop, I becomes 2. So when I becomes 2, your I is here. Right? So your I is here. Again, you get inside, start comparing 2 with 6. Yes, 2 is smaller than 6. So therefore, your 2 and 6 are swapped. 17, 4. This will be your new array. Now, so your I is still here, second position. Then when you do swapping, so this has become the new array. What you do is next increment j. Your j is here, I is here. So 6 and 31 compared. Yes, 6 is smaller than 31. So therefore you would get the new array 31, 17, 4. Now as you know, I is still pointing to 31. How you compare with the rest of the elements? This will not be swapped. So now exit this inner loop and then come back to the outer loop where now I value is 3. When I value is 3, right, what happens? So I is at 17. When I is at 17, so I'll write it here for easier understanding. So 2, 6, 31, 17, 4. So your I is now pointing at 17. We'll do this iteration, right? So when you I is here, j starts from here. So compare. Array of I, 17 less than 2? No. 17 less than 6? No. 17 less than 31? Yes. So swap these two. So your new array would be 2, 6, 17, 31, 4. Your I is still here and j moves here. So array of I, 31 less than 6, no. 31 less than 17, no. 31 less than 4, no. So now to exit from this for loop and come back to here, increment I is 4. So I is 4. So when I is 4, our n we calculated at 4, so our condition should be less than or equals to. Less than or equals to. Well, so you come back, again start, your I is here, j starts from 2. So you compare 2, array of I, 4 is less than 2, no. Is 4 less than 6, yes. So you swap 2, 4, 17, 31, 6. Now again, your array of I is here, the value is 6, j is here, compare 4 and 6, yeah, we swapped that already. Now 6 and 17, yes, so they swap them, 4, 17, 6, 31, 17. Your I is still here, now j is moved here. Then last one, what do you do? Array of I 17 and then less than 31, yes, so swap them, 2, 4, 6, 17, 31. So when this is complete, right, this loop is terminated, come back, I has incremented to 5 is 5, no, not sorry, yeah, 5 is less than or equal to 4, no, so you come out of the loop. By the end of it, your new array, if you take a look at it, it is sorted in ascending order, right? So this is what a simple sort validation of the algorithm that you have written. See what, if you have seen while validating, we realized that when you take n as equal to the array size, you have to make the equal sign. If you make n is equal to 5, the less than would do. But because we considered n is equal to 4, we have to make it as less than or equals to. And so as here. And this also we realized when I was walking through the code, that minus symbol is missed. So that's the importance of validation. So it is very important to validate the algorithm as well as your code with a dry run first. And then you go get onto the computer, code it, compile, run it. Hope now you have understood the simple sort from the beginning till the validation. Right? Now you know how to identify the problem, how to derive an algorithm from it, and then how to translate that algorithm into code and validate it. Thank you for watching. For more details, visit vsdevelopers.io.